Well, yes, Haley. And what's important to understand here, and we talked about this at 4 o'clock, but I'll just quickly recap it again, is that the energy from the sun does not heat our Earth's atmosphere directly. It heats it indirectly. Basically, the energy comes from the sun in short waves, and it's able to pass through the atmosphere relatively unscathed for the most part. Let's go ahead and take this full screen here. And we'll show you that, that, again, energy from the sun emitted in shortwave radiation. And what that means, it's little wiggly packets of energy, and it's able to wiggle on through the dust and the carbon dioxide and other things that are in our atmosphere right now, and able to make it all the way to the Earth's surface, and it does not heat the atmosphere. The sun's energy heats the Earth. Then the Earth re-emits that radiation in long wave radiation, and it has much less wiggle, much less ability to move around a little bit, and so it gets trapped by the dust, by the carbon dioxide, by the methane, anything else that's in the atmosphere, and it just kind of bounces around. Very similar to a greenhouse, which is why we call it a greenhouse gas. The energy from the sun passes through the glass panes, heats the surface of the inside of the greenhouse, and then re-emitted as long wave radiation. It doesn't have the ability to wiggle on out, and so I say it's trapped in the greenhouse. Same idea here in the Earth's atmosphere. So, with carbon dioxide being a primary factor in trapping the energy here in the lower elevations or lower levels, do we have an increase in carbon dioxide in our atmosphere? Heck, let's not go back 1,000 or 2,000 years. Let's go back 800,000 years. And yes, we are at much higher levels than we have been in the past 800,000 years. And so with all that extra carbon dioxide in the atmosphere, that is trapping that energy that is being re-emitted by the Earth down here towards the surface. An analogy of this, if you will, this is kind of an extreme analogy, but an analogy nevertheless, is comparing Earth's atmosphere to Venus's atmosphere. Earth, we have a little tiny bit of carbon dioxide in the atmosphere, just a little tiny bit. Venus's atmosphere is mostly carbon dioxide, and the average temperature on Venus, 864 degrees because of all that carbon dioxide. I know you're saying, okay, Venus is closer to the sun, that's it. Mercury is closer to the Venus to the sun, and Mercury is cooler than Venus. It's the carbon dioxide and other gases like that that trap the energy down here towards the surface. And so the more carbon dioxide, methane, whatever you got in the atmosphere out here, that's going to keep those things trapped here in the lower elevations and heat us up.